polynomials. Remember, polynomials are just expressions that have variables with whole number exponents. And so when we do our multiplication, we have to remember our rules of exponents. First of all, here we're going to do our distributive property. We end up with negative 6x to the 5th because we're going to add our exponents 2 and 3. And then we distribute here and also get negative 15x cubed. Notice that this multiplication is simply the reverse of factoring. Likewise, when we move down to this one, we're going to do the same thing. We're going to multiply across by distributing. So we're going to end up with negative 4x to the 8th plus 8x to the 7th when we add our exponents, followed by a negative 12x to the 4th. In each of these cases, we were multiplying a monomial by a polynomial. But what happens when we multiply two, in this case, binomials by each other? This is where we have to remember the process of FOIL. We're going to multiply our first terms, which gives us x squared, our outside terms, which gives us negative 3x, our inside terms, which gives us positive 4x, and our last terms, which gives us negative 12. We do have two terms that can be combined because they are like terms, resulting in x squared plus x minus 12. Again, this is the reverse of factoring. If we applied the AC method and factored this, we would return to the x plus 4 times x minus 3. In our last example here, we have a trinomial times a binomial. So we have to perform the distributive property with both terms. I'm going to multiply here, which results in y cubed. Multiply these terms, which leaves me with negative y squared, and multiply these terms, which leaves me with plus 4y. However, I also have to do the same thing with the 3. This gives me plus 3y squared, followed by minus 3y, and then last but not least, plus 12. Now we must look for like terms. There's no other y cubed, so this remains. There are two y squared terms, results with plus 2y squared. There are two y terms, which results in a plus y followed by plus 12.